Hello, hello, hello. Is this thing on? Okay. This is stream number 57. I'm going to continue my work that I started yesterday, making a library I call Twitch, because I am not very creative. It's a library that's going to be used to interface with Twitch, and specifically, at least to begin with, the Twitch Messaging Interface, or TMI, which is roughly based on IRC, but with some twists. We started that work yesterday. I got about 2 hours into it, and there's a bunch more hours to go. So continuing the work on establishing the Twitch library for interfacing with Twitch. So if you haven't seen my stream before, or you're seeing this for the first time on YouTube, on my Twitch channel, there's a link to my OneNote notebook, so you can see all of this. And in the log section, there's a page for every time I stream, which is why I say this is stream 59, because there are now 59 entries, with some one-off things here and there. Mostly at the beginning, I had some one-off videos. But for the most time, or for the most part, these streams have been building a web server and web client, web tech. But I'm deviating a little bit in order to play around with Twitch. Although it's sort of similar, where you're going to use a lot of the same communication libraries that I've been building up, like sockets, web sockets, that kind of thing. And I'm also taking some of the chat bot stuff I had built into my web server and just moving over to Twitch. So it's just the underlying low-level tech is changing, but the same bot is there that you can see. I don't know where it would be. Around, I guess it would be stream 34. We started to introduce this idea of a chatbot called MathBot 2000, and it would ask. Actually, let's just log into the web server. I'll show you. I'll show you what's going to be in my Twitch channel, hopefully, in the future. Oh, wait a minute, I can't, because I took it offline. Never mind. But anyway, it will be, if I were to pretend that it's up, it would be something like MathBot 2001. Let's say, what is 5 times 3 plus 2? And then if like Joe answers 12, you would get a response saying, sorry, Joe. That's not the right answer. And then say Mary would answer 17, and then MathBot 2000 would say, congratulations, Mary. That's the correct answer. You now have 15 points. Something like that. And I had this running in my web server through a client that my viewers would download in their web browser and connect to the server. And the MathBot was built into the web server as sort of an extension to the web server, like a plugin. But now the idea is we're going to actually make it a part of the Twitch chat. So the first part in doing that, if I would do a little bit of review from yesterday, I had done some research before on how do you write a Twitch bot. And there's a starting point from the dev Twitch TV. But quickly you'll find out you need to know two things. How to get an authentication token, this OAuth thing. And I kind of leave that up to the viewer to figure out how to do that. I'm not going to show the tokens I got, because that would be bad and people could just steal it. But, follow the guide, get authenticated. And then the second part is really understanding the protocol, which is based on IRC, but they have a really nice guide here. If I need to get that open on the correct window. They have a nice introduction where it says you can read about it, the old IRC protocol in this RFC link, or very roughly, here's what you connect to, and here's what the connection session looks like. And that's what we were working on yesterday. The essential first two lines of text, and it's a text-based interface, which is also kind of nice. Makes it more approachable to people writing stuff at this low level for the first time. So yeah, the first two lines will be your password, which is really the token, the OAuth token you get, not your real password, but the token you get from doing the OAuth protocol. And then your nickname, so basically your Twitch name. And if we're successful and we're talking to the real Twitch server, we'll get a nice greeting, and then you can use IRC commands, which they have down here, like join, in order to join someone's channel, and then you start to receive chat, and then you can send chat and all that good stuff. So we're probably not going to get that far today, but I was working on the essential connection stuff yesterday. I'm going to continue that today. So I use test-driven development. So specifically in C++, I use Google Test. So that's this gtest folder. We include the gtest header, and then we get, if I collapse that, we get a base class called testing test, and we're overriding that or making a derived class, and this is what I call a test fixture. And this test fixture is used in these tests here, and I have 4 of them. 2 of them are empty, but I was working on the first 2, which are pretty much complete. And test-driven development involves you first writing the test. The test will fail because you haven't written the real code that you're testing. You just get that up and running so that it compiles, and then, of course, the test starts out failing. Then you go fill in the code to make the test pass. And then when you're done, you have the test that you can keep running over and over again if you want as you change your code, and it sort of validates that you didn't break anything. But it also serves as documentation and a guide on how to use your code, because each test describes a use case. Like, for example, this one's how do you use the class to log into chat and log out of chat and receive messages from Twitch and send messages to Twitch, right? So I have basically specified here with this TMI class, you first have to set a function that you want called when you're logged in, and then you call login, and then you wait for that logged in function to be called. Pretty straightforward. And then what the test does is it says, with the help of something called mocks, it tests to make sure that the code actually did what it was supposed to. So the test doesn't actually run the code directly with Twitch. We make a pretend Twitch, which I'm calling mock server. It's a fake Twitch server, and really it's just testing to make sure that our TMI class is doing what it's supposed to, so that if it was talking to the real Twitch, it should work. So for example, we ask the mock server, hey, did they connect? Was there, expect that there was no connection problem. We check to make sure that the nickname offered was the one that we told the class to use. We expect that we got an OAuth token, and we expect that it came in this order, the password and the nickname. So I had written this test. The tests are pretty much complete, and we were just filling in the mock. And then after the mock, we're going to fill in the actual code. One thing to note here, this is asynchronous programming. So whenever when I call something a delegate, it's the same as a callback. When we're setting a delegate or a callback, we're basically telling the class, hey, in your own context, call this function when something happens. Asynchronous, right? So log in, this function will return before we're actually logged in. It just starts the process of logging in. Our TMI class has a background worker thread, which does the real work. And in that thread's context, it'll end up calling our delegate when the login is done. So our test has to set up that callback, and I'm using a modern C++ lambda function. So that's what this weird syntax is. This part of the lambda expression is capturing the variables we want to use, and here's the function itself. And the second thing is, because it's asynchronous, we have to wait for things to happen. So that's what this code is here. After we call login, we're waiting for this logged in variable to be set to true. And we do it using a condition variable, wake condition. And this is based off of POSIX threads, POSIX condition variables. It's part of the C++ standard now. And with a condition variable, you have an associated mutex. And the standard convention is, using a unique lock, you grab that mutex, then you tell the condition variable you want to wait or wait for something that needs the lock to synchronize access. And then in the case of wait for, there's a timeout. So if it goes longer than 100 milliseconds, it returns false instead of true. And then here's the condition expressed as a predicate, which is another kind of callback. In this case, the condition variable is going to check the predicate by calling this callback, and if it returns false, then it grabs the lock and goes to sleep. And in this code over here, where we actually set that logged in, while holding the lock, we call notify in the condition variable, and that wakes up the original thread, which will then call this predicate again. It'll return true this time, and then we continue. If this didn't get called, this timeout period will have elapsed, and it'll return false. And then, because we have an assert true, the assertion fails, or test fails, right? So that's pretty much the pattern here. It's asynchronous programming using a class that has a worker thread, and some functions are going to be synchronous, like setting callbacks or delegates. Other ones are asynchronous. So yeah, I was working on the mock, the pretend server. I think I was around here. Yeah, so here, the mock server is implementing this interface, Twitch connection, which we just defined yesterday. Show that to you really briefly. It's not much yet. So whatever class we're going to end up writing, which will make the physical connection to Twitch server, right now has two methods. One is connect, which basically is a synchronous call saying don't return until you've tried to connect to Twitch. And if it's successful, it's return true, otherwise return false. Then, presumably, once it's connected, you can call send, which is asynchronous. And that just queues a message to be sent to the Twitch server. So we haven't handled receive or anything like that. We're just building it up piece by piece. Hey there, Sourcify. How you doing? Can I increase the font size? You mean this window? Or this part over here? This part over here, I'm not sure how to increase the size. I can make this one a little bit bigger though. Make it slightly bigger. I don't know how to increase the font size of this part over here. If anybody knows, please let me know. Yeah, so this, we're going to implement twice, right? We're going to make a pretend one for our test framework, and then we're going to have to make a real one later to talk to the real Twitch. I like to do things incrementally and start with a unit test. So we're just testing our class, so we have to simulate the entire world around it, including the Twitch server. So I'd implemented connect is very simple. If we're already connected, it's obviously a problem because they call connect twice, so it's a problem. Return false. Otherwise, we're connected. We pretend it's all connected now. We return true. No problem. So send. This is what we're working on right now. If it's not connected yet, it's a problem, right? Otherwise, we're going to basically pretend we're the server and we're going to interpret the text coming in. And right now there's an assumption that the message is a complete line, and that I don't know if we want to assume, because actually it depends on how I wrote this. It just says a message. It doesn't say if it's a complete line or multiple lines. So I think to be safe, before I do this matching, I want to have like another variable that holds on to everything we've received so far that haven't yet parsed, and just like append the new message to it. So something like data received plus equals message, and then we can do the substring on data received, and we make that just a local variable. And it replaced string with string cat, which means probably I didn't include string. Oh, no, I did. That's just a temporary thing, I guess. So this data received will be kind of holding on to all the characters we've received so far, but haven't yet interpreted. And then I think before we want to do that, we want to wait until we receive a full line of text, because both IRC and TMI are based off of lines of text, and then only scan one line at a time. So to do that, I think what we'll do is we'll do data received find CRLF. I think we already, whoops, did not mean to press that. I think we already declared that somewhere. Or maybe it was in messaging CVP. Yeah, here we go. So we'll make a copy of that. Just making it constant so I don't have any magic numbers, although it sort of is self-describing. It's the required line terminator for lines of text. Right, so we're going to search for that. So it's going to be, we're going to store that in a temporary variable called line end. And then we're going to see if line end equals the standard string end no position. so no position, meaning it didn't find the character turn line between, then we can return early. Otherwise, I think what we'll do is we'll pull off the line and just scan that one line. So something like this. So line is data reseed substring from 0, and then the count will be to the line end. We won't include the CRLF. How about that? But then the data reseed will be the leftover. So there it'll be from the offset of line end plus the length of the CRLF, which is 2 obviously, but it's better not to use magic numbers. And then we can just interpret line. I think we have to, right now, we'll have to handle later, but for now what we really want to focus on are those 2 substrings that it might be, which is pass and nick. And there's an important thing is there's this space here, because they might do something like that and it's not going to be a valid command, right? So that's a valid command. Okay, so in the case where it's pass, we expect that the rest of the line is the token, right? So we had a way to get the password offered. We didn't actually have a variable for it, so let's make one. Actually, while we're at it, we'll make both nickname offered and password offered. Nickname authored, password offered. And here's where we'll say password offered is line substring 6. And if you don't have a second argument, it goes to the end of the line. And then here it's nickname offered 6, right? Now, that's sort of a naive implementation. One thing I ought to do is make sure that according to the IRC protocol, like, for example, they say it'll be pass. I can increase that font size. Pass. That's weird. How come it? Oh, if I zoom in too much, this panel goes away. They have pass in a single space and then the rest of the string, but I'm wondering, can you have 2 spaces there? This probably doesn't talk about it, but maybe the underlying RFC does. So I'm just going to check really quick. Open that in a new window. And where might they have that? Probably in the syntax. If you want to go really pedantic, we'll look at usually at the near the end somewhere. Okay, this is a lot of the times in RFCs they have the pedantic syntax near the end, but I didn't see it there in the table of contents. Let me search for a word where we might see it. Okay, now this is general information. I need like message syntax. Okay, here we go. Okay, they say or more. Okay, so we got to be prepared for there being more than 1. Okay, so let's do that. We'll be flexible about it. I actually have a helper function we can use for that. It's in my library called system abstractions, which I am not finding because it's not listed as a dependency. So let's fix that. Dependency of our test. I forgot to mention at the beginning of this stream, I kind of talk about it every other stream. I use CMake to make my build system. So this is the CMake language. It looks a little bit weird if you haven't seen it before, but this is what's used to make the Visual Studio project files. And here's one specific place where I can list the libraries I need to link with and get headers for. So I just add system abstractions to this target link libraries for this, which is Twitch tests. And then I run CMake again, then I should be able to include that library. Just go to the build directory and type CMake dot and it'll update the project files. And if you're on Xcode or some other build system, exactly the same thing. The first time you run CMake, you tell it like, do you want Visual Studio files, Xcode files, or whatever. Subsequent times it just reloads from the cache. All right. So now I should be able to hit, I'm hitting control space and I get system abstractions, and then I think it was string extensions. That's what I wanted. So I think, if I remember correctly, it's system abstractions trim. Trim, yeah, here we go. So makes a copy of a string and removes any white space in the front and back. That's exactly what we want. So it's just password offered. And while we're at it, we'll do the same thing for the nickname. Okay, and then that should satisfy that and that. This part, though, is get lines received, is going to fail until we basically capture every line. So instead of returning an empty vector, we'll return lines received, and we'll declare that as another variable. Lines received. And then this one's pretty straightforward. Every time we get a line, we'll push it into the back of lines received. And just we need to return that. Oh, I already did that part, right? Oh, we need to have this clear lines received as well. That's just lines received clear. Now, our mock is complete. I just hit build and there was a little bit of a lag there. I don't know why. It's building. Just want to make sure it builds. It's not going to pass yet. To run it, it's Twitch test, debug Twitch tests. Yeah, so it's still failing. This is what Google Test gives you when a test fails. Actually, here's an example of when it passes. You get an OK, otherwise you get a failed. And it gives you a summary at the bottom, how many tests it ran and how many passed and how many failed and which ones failed. And then for every assertion or expectation that fails, it kind of shows you the line number, what the value you're testing actually was, and what was expected. So it was actually, the logged in was false. We expected it to be true. That's because our code doesn't actually do the right thing right now. It's basically a skeleton that doesn't do anything yet, and we have to fill it in now. So I'll recap from yesterday. It's asynchronous, right? This the login part. What it does is creates an action object and says the action is login. Here's the nickname and token. Pushes it onto a queue, and then, like I was saying earlier, we coordinate with another thread using a condition variable. So in this case, it's wake worker. We notify the worker thread by notifying that condition variable. Meanwhile, our worker thread, which will be waiting here for either being told to stop or for actions not to be empty, it'll wake up, loop back up. We're not stopping yet. And then we'll get into this loop because we have actions. It's going to take the first action, pop it off the queue, and here it'll go into login. And here's where I guess I did fill in the code. So it actually should have worked, except for this part. I think that's why it's not working. Maybe? Actually, it should have done that. Interesting. Oh, wait a minute. No, yeah, that delegate is not being used, right? So we had this logged in delegate. We're forgetting that code. It's set, but it's never called. Oh, I remember why. We need to do a little bit more in our mock server, because if we go back to this thing, we don't know we're successfully logged in until we get this junk, right? So we need to have our mock server do a similar thing. There's more to it. But yeah, the gist is if you get a welcome message, then it succeeds. I wish they would show what you would get if it failed, but they don't show it here. Yeah, I guess for now we'll just do a naive implementation where we'll wait until we get, essentially this is saying it's a message from the server. Actually, maybe we can look up this code. That code we can confirm. Oh, it's not in the command responses? Interesting. Okay, it's not an error reply. Interesting. Yeah, so like, here's where it gets a little bit difficult because Twitch API, Twitch documentation is not really complete. It doesn't really document anymore. What does that 1 mean? I just happen to know that the 3-digit number here is a command code number, and the underlying IRC protocol defines a bunch of them, but that 001 wasn't anywhere in there. I bet if we looked up 376, we'd find it though. End of message of the day. So we could actually wait for that. The rest of the line is really intended to be consumed by the human user. It's this 3-digit code that's supposed to be the machine readable part. Yeah, so there's going to be a message of the day 372 also, right? Yeah, so we can interpret that as the message of the day, and we can actually send that up to another callback if we wanted. Oh, thanks, Eric. BizKick. How are you doing? I've been practicing a little bit. This is my 59th stream, so getting there. But I'm still working on it. I slur my words sometimes, so my apologies. So, yeah, I think what we need to do... Well, maybe we'll just make it very naive right now, and we'll just call the callback at this point. So if log the in delegate not equal to null, we'll just call it. We won't even wait to get anything back from the server. We'll just call it, right? That ought to get us further in our test here. Okay, got a little bit further. Looks like we chopped off the nickname authored though. By the way, this OAuth token, I just, you know, typed a random string like that, so don't try to use it. It probably won't work. Yeah, it looks like it's chopping off the first character. So maybe I had an off by 1 bug in my fixture. 0, 1, 2, 3. 0, 1, 2, 3, 4. Oh yeah, I am. Off by 1, right? Off by 1 bug. Okay, there we go. So log into chat works. Logout isn't working yet, so we expect the logout delegate to be called, so that's easy to make it pass, right? We can simply call it. Log, I guess I kind of want it down here because I'm leaving these little placeholders for things I know we need to add, but I just haven't written the test first. I'm trying to stay test-driven development and only write code to make tests pass. But as I'm going through the code, I'm like, obviously we're going to have to really call close on the socket here. I just don't have anything in the test framework to check that yet. Okay, so we're getting there. We're not sending the correct farewell message. Oh, okay. We didn't have any provision to put in a farewell message, so let's add that. How did I write the test for that? Farewell. Oh, okay. So it really just needs to be passed in there, right? So that was a bug in the test. Fixed the bug in the test. The bug was that we had no way, we weren't actually passing in the farewell message. Now we are. It won't compile because the code isn't correctly specified. Got to go into the specification for our API and fix it, so it'll be here. And what are we calling that? A farewell? I don't know if that's the right word, but farewell is kind of a nice word. I'll keep it for now. This is the message to include in the command sent to the Twitch server when the connection, or just before the connection is closed. All right, and now the green squiggly means there's no method that matches this prototype. There is a logout, but it doesn't have an argument. So I'm going to right click and go to definition for a nearby guy. And then we see this one's a red squiggly because it doesn't match any declaration. We fix that. Now it matches. I just need to put it into our action thing. I have a message slot, so to speak, so I'm going to put it there. And we just need to use it here. Actually, I already am using it. Look at that. I just forgot to set it. So this will probably get it to work. And there we go. So the code here sort of indicating that we're missing some things in our test. So we're going to need to write a test that requires us to do something here. Right, so this is if we tell it to log in and then we tell it to log in a second time. Does that actually even ever get there? I guess it will. And I guess in that case, what do we expect login a second time to do? Let's say we don't expect it to do anything. It'll just get ignored. So we'll write a test for that. We'll say log in when already logged in, right? And what do we expect to happen? We'll start off by just copying the logged in thing. Oh, wait a minute, no. I'm going to take advantage of the fact that logout uses a helper login function. Because it was going to be repeated in a lot of places. We made a helper function yesterday that has all the logic to log in when we're not actually testing login. Kind of the same as the log into chat test. It's the same code here as in the login function, only I need to have it here explicitly because we're actually testing it. But in these other tests, we don't want to retest what another test already tests. So this is just to eliminate code repetition. So we'll start off with saying we log in, and then the testing part is we're going to try to log in twice. It's like log in again as if we didn't log in. And this is how I think I'm going to do it. And I should probably document this, so because it's only one line, it's easy to be missed. So log in normally before the test begins. And now try to log in again while still logged in. So it has much the same code, only I think what we want to do is we want to assert false here. In other words, we won't get this logged in delegate called again because we're already logged in. It'll just get ignored. So I believe that right now will fail. It passed. Okay, so I think we have a bug. Why would it pass? Oh, I think it's because there's no logic here. No, that's not it. Why would it pass? It would have logged in, still had the connection, but it would have ignored it and just gotten another one and then sent some stuff and called the delegate. So why is it that... Why is it that it passed? Okay, see you, Eric. Kick. Yeah, we'll get the bot in maybe 2 or 3 streams. That's what I'm guessing. Have fun. All right, so like I usually do, and I'm not exactly sure what, like it's not obvious what the bug is, I like to just use the debugger. So I'll right click here, say set a startup project, and then set a breakpoint here and log in. Actually, technically, yeah, we'll set a breakpoint there. And we'll just tell it to F5, which is start debugging. It'll hit there, and then we want to set a breakpoint in the worker when it actually is performing that. Hit go. Okay. So here, you can see connection is not null. It makes a new one. Oh, I think the problem is in our mock factory. Because it thinks it's already connected. It's using the same connection object. That's what it is. It's our mock server. How do I show this? Yeah, it's in our fixture. When we set up our mock connection factory always just returns the same mock server. Maybe what we want to do then, instead of doing the creation of the mock server here, maybe we want to do it here. We'll start off, we'll have it always create one to begin with, just in case we want to use the mock server. Let me think about this. Yeah, see, we don't want it to return the same connection every time. We want it to make like a new connection to the server every time. But if I just reassign mock server, then the tests which use the mock might be talking to the wrong mock. Actually, I think for now we're good if I just, where was that code again? Just move this assignment in, so just basically do it here every time the factory is invoked. So this is, we're giving the TMI class a function to call whenever it wants to make a new connection. And so instead of giving it the same one every time, we're going to make a new one every time. And we won't have an initial one. So now it won't think it's already, the server won't think it's already connected. So there we go. So it logs in, it does a second login even though we're already logged in. So the fix for that code will be here, where we simply, I think we just simply break out of that switch, basically goes to the top of this loop and basically just discards that action. So it'll ignore a second login attempt. And there we go. All right, so the next thing I had here, okay, if connect fails, what do we want to do? We need to have some way to tell the user the connection failed. So for that, we need a callback, because right now the callback I have, there's only one for when we're connected. So going to Twitch, header messaging. I have a logged in delegate, logged out delegate. Let's have like an error. Error delegate. Either error delegate, or we can make this, instead of logged in, we can say login result. Actually, you know what I like better is calling the logged out delegate. Yeah, let's say, we'll just change the text here. This is the function to call when the user agent completes logging out of the switch server, or when the connection is is closed, or could not be established in the first place. So it's kind of a catch-all that will be called if like the connection fails or is broken midway. So we'll just need in our test to call the set logged out delegate as well. So here we have to engineer that the login fails. So we need to test for it first. Get rid of that breakpoint. Okay. Login, how about calling login failure? Okay, yeah, so here it's a little bit of a sticky situation, because the login fails if connect returns false. Connect will only return false if we're already connected. So two things, I need to introduce like a fail connection attempt. Defaulted to false, but we'll let the user set it to true. Fail connection attempt. And then we have to basically create the mock before the connection factory is called. without breaking the other tests. So I think I'll have what we'll do is we'll have a flag is connection created by UnitUnderTest. This flag keeps track of whether or not the unit under test has created a connection. And then that way what I can do is I can do this initial create up front. Like that. And then down here I can say make a new one only if connection, if it's already created one, then make a second one. And then we just always set it to true out here. Then I can we've preloaded the mock so that we can say mock server fail connection attempt, and then we can try to do the login. And let me document that too. I'll say first set up the mock server to simulate a connection failure. And now try to log in. And so what we expect is the logout delegate to be called this time. Set logout delegate. Like that. And then we will assert true that the logged out is called. Sound good? So this will fail, right? Because it won't call a logout delegate. Oh, why did that? Oh, that's a copy paste bug that never needed to have a return value. Okay, so this ought to fail at first, right? So it's not calling the logout delegate when the connection fails. So we fixed that. Basically, it's like if we logged out, right? So right now there's no error message per se. We could add that later. That's essentially what I want to do though. Okay, still didn't call it. Oh no, it's a login failure this time. No. So I'm confused. Okay, it's still not working. What did I do wrong here? Connect would have, oh, hold on. I didn't finish my thing here. I set up that flag, but I never used it. If fail, then return false, right? To simulate a connection failure. That's one kind of connection failure, I suppose. The other kind is when the server doesn't give back a message of the day. So we haven't gotten to that yet, but yeah, so let me, just a sanity check, let me undo this change here. Verify that breaks the test. The test is set up correctly. It's expecting something and didn't happen, and when we put the code in, like that, now the test will pass, right? Cool. Okay, so I'm just going through all these to-dos to clean them up at first. So here's another thing. So we expect the connection to be closed. Yeah, so we don't have a close method of our connection interface yet, so we kind of need to add that. Let's do it from this point out, so to speak. So we'll put in the code. Connection close. Okay. And then red squiggly because it doesn't exist yet, and then we have to add it here. Actually, you know what? Maybe close will be just releasing the class itself. So instead of explicit method, actually no, never mind. I do want an explicit method because we have one for connect. Furthermore, I kind of want to balance connect and call it disconnect. That way I like to keep balance. So we'll have connect and we'll have near it disconnect. this method is called to break an existing connection to the Twitch chat server. It's a synchronous call. The connection, actually, we're going to always assume it succeeds. The connection will be disconnected before the method returns, and then we don't need to return anything. Because we really don't care if disconnect fails. It's sort of, well, what are we going to do about it, right? Kind of like closing a file. If closing a file fails, what you going to do about it? Maybe report an error, but I have in mind to have a separate way of reporting errors anyway, not through the return value here. I need to build that in soon too. Anyway, we're going to have a disconnect. Now, we're going to run into the problem where our mock server doesn't implement that disconnect, so if I attempt to build, it'll say mock server is abstract, right? It's because it's missing that method. So virtual void disconnect override. Now it should build, but we haven't written a test yet. Oops, I forgot to write the test. Oh no, I do have the test. We forgot to update it. It was log out, right? Log out of chat. We expect to see the logout delegate called, and we expect to see that sent, but we also need to expect true mock server. We have to ask it similar to is connected, like is disconnected, something like that, right? Where's the login tested? Is connected? Something like is disconnected. So we'll need to add that. Is disconnected. Bye. Got people leaving, saying bye. Is disconnected. Return is hold on, I'll be right back in one moment. 1 moment. Sorry about that. Just saying goodbye. And we hit the wrong button there. Is disconnected. So obviously we're going to have to set it here, right? Actually, and that's good enough. It made me think I should maybe beef up my other tests, like not login failure, but log into chat. Should make sure that we're not disconnected at any point, right? Yeah, let's do that. Let's do expect false mock server is disconnected. We had was there a connection problem already, but I didn't have this check as well. And we'll just turn that around down here. Oh, we already have that. Never mind. So we expect to be disconnected on a logout. We don't expect to be disconnected on a login. All right, so let's try that out. And yeah, since I messed up there, I wrote the code before I was finished with the test. I should like undo this and verify that the test would have first failed, right? And then we put the code in to make the test pass. Cool. Yeah, I'm gradually building up my tests. So actually I'm at a point where I feel comfortable checking this in and putting it up to GitHub so that people can follow along if they want or look offline. So, and I haven't done that yet, so let me do that. And I can explain a little bit about how I use Git, which is it's a little bit different from other people. So, okay, that was just an example I was playing with before, right? So I use a tool I wrote called Nugget because I like to have multiple Git repositories. So, for example, my web server's in one Git repository, and my WebSockets library is in another, and this Twitch library will be in yet another. And the tool I wrote basically works with Git and a manifest file that looks like this. And it's like XML, very basic, that has an element for every second level Git repository where the manifest itself is checked into the top level or root repository. So we just need to create the Twitch repository. So we already have it in the file system here. We just need to do a git init, do a git add a, let's just give it a message, initial revision. Oh, that's part of commit, isn't it? Getting my commands mixed up. Just git add a dot and then git commit -m initial revision. And then I'm just going to take the beginning of one of these and say git remote add origin, paste, no, that wasn't supposed to be multiple line. Copy and then paste, and then we're going to expect it to be called twitch.git. Then I'm going to do a quick thing off stream because I don't want to leak any personal info, but I'm going into GitHub just to create that repository just as an empty repository. And create. Okay, so now I should be able to push it. Git push set upstream origin master. And push it successful. And then I'm going to do two things. I'm going to do Nugget add Twitch. That does in its own step two different things as well. So it will have added this element. It also goes into git ignore and adds it here because we don't want the top level repository to say that there's something added when it's really not supposed to be in the top level repository. It's in the sub one. So that's the first thing. The other thing is, since I have two copies of this manifest, one for if you have a GitHub account, so it uses SSH, and then if for people that don't like having a key or whatnot on GitHub, there's the HTTPS version, so I like to keep those in sync. That I don't have a Nugget command to do, so I just kind of do it manually. I kind of see, okay, it's near TLS decorator, go to the get XML TLS decorator, and paste that, and then I just fix up the URL here. So instead of git at GitHub, it's HTTPS : // right? And then there's a slash here instead of a colon. There. Yep. And then we'll make our check-in to the top level. So here it's added Twitch. And sorry about the bright white. I wish I had a dark theme configured for Git GUI. And I'm using Git GUI only because I'm really used to doing it for years and years. So, oh, hold on, someone's at the door. All right, I'm sorry. I am back. That was someone at the door. And it was actually weird. They don't usually go door to door, but it was for the upcoming election. So anyway, let's move on. So git ignore gets an extra line here. What am I coding? I am making a library that we're going to use to interact with Twitch. So I'm following along the Twitch developer guide for making chatbots in IRC. So I'm about at this stage here where I'm writing a C++ class to do this kind of exchange. And the ultimate goal is we're going to make a Twitch bot in probably the next 3 or 4 streams, I'm guessing, in the form of a C++ class. So we'll be able to write a program that uses this class to log into Twitch and interact with us on chat. So that'll be fun. And right now I'm just checking in the code so that people can look at it. It's all in GitHub. So, and oh, by the way, hello, Maker Marker. You must have came in right when the door-to-door guy rung the bell. Okay, so we added Twitch as a sub-repository. We added it to the CMake yesterday. And then here we're adding it to the manifest so that my Nugget tool can pull and push. Or really just does pull right now, but and we're going to say add Twitch repository. We add Twitch to solution. Commit that. You're the door-to-door guy? Oh, you're really good then. To tell me which congressional candidate he was wanting me to vote for. I'll be really impressed if you know that. It's Git GUI. It's a really old school way to stage and make commits. So I tried out GitHub desktop and what was it? Source tree, but I'm still kind of used to this. Okay, we don't need to push that because we're done. I'll tell you really quickly why I use Git GUI. I still like it. If you're doing something like this and you want to just say, I want to only stage those lines, it's actually pretty easy to do it. Stage the whole hunk. And I haven't yet found a tool that I like, that I'm comfortable with, that does that. It's replacing GitHub Desktop or Source Tree or Tortoise Git. It's just an older way of doing it. Nugget is my own tool that I use to handle these multiple repositories. So for example, I can run that and it'll tell me there are no changes. And if I do that, it'll actually go upstream and make sure that there was nothing I might have pushed from another machine. And it'll also list out all my sub-repositories. GitHub Desktop is pretty good, but I just wasn't comfortable with the interface for, I think it was for staging individual lines. I figured out how to do it finally, but I didn't really like it so much. How long have I been coding? About, oh, I don't know. Doesn't it say in my panel below? Let me look at my own panel. Oh, I can't while I'm streaming. I've been programming since like 1983, but it's all been mostly hobby stuff. And professionally about 25 years. Which means, since C++ has changed a lot since then, if we're talking about like what I'm doing now with modern C++, I've had to unlearn old C++ in order to learn this modern C++ stuff, so I'm still learning. I'm not the best at this, I'm still learning, and you guys are helping me. If I sound like a professor, I will take that as a compliment. I'm trying really hard with my stream to have this notebook to write down all my research, and every time I stream to have a plan. And if I was a viewer, if I put myself in my viewer's shoes, I'm not going to watch every single stream. I might watch, once in a while, and I might want to catch up and see, well, what was he working on the last 3 or 4 streams? And then get a sense of, is this something I might want to watch later? Roughly how quickly is he developing things? And so I would want this, so that's why I give it to you guys. Also, you guys give me a lot of useful feedback. How am I with MLs? I'm not sure what MLs are. Sorry. You'll have to tell me what ML stands for. Let's see. Yeah, right. We have everything checked in. I decided to check everything in there because we got to a good point where we have some, not all of these are done, but we have the login, logout, baseline done. Machine learners. Like machine learning. That's really popular in the last workplace I was at, the last job I had. It was really popular there. I know a little bit about the concepts, but I haven't done any work directly on it yet. So, actually, if there's someone out there on Twitch streaming machine learning, I'd love to watch it. So if you know any machine learning streamers, go right ahead and give a shout out to them. I will pick it up and watch them later. I don't know enough about machine learning to stream it yet, though. Oh, you. Okay, shout out to MakerMarker. Let me make a note about that. Notes. See, I have this section for notes and all that. So check out MakerMarker's stream machine learning. No. You do stream, but you don't know enough yet. I'll still check it out if you have a stream. In a few months? Why not? I review my notes every once in a while, so I'm expecting you to be good at machine learning in a couple months. I'll be watching. Yeah, I think it's a pretty important topic, and I don't know enough to stream it yet, but maybe someday. Okay, I'm at a stable baseline for login and logout, and I had these placeholders for sending, where are they? Sending and receiving messages. I'm trying to decide, do I want to work on that, or do I want to implement the rest of this little protocol? Because right now we're just assuming if we can send the password and nickname, hey, we're logged in, right? We really should be waiting to hear back from the server, and for now, I'm just going to use the naive assumption that if we get back this message of the day, then we've successfully connected. Actually, I'm thinking about doing that. So we'll update our login test to wait for that message. And this login failure, we got to qualify what kind of failure. So this will be a failure to connect. Then we'll have another test, messaging test. Login, did I spell that right? Copy paste to make sure. Login failure. I don't know. No message of the day. And then how about another failure? We'll keep it blank for now, but I don't want to forget it. It'll be login failure. Oh wait a minute, no, we have not connect. How about disconnect? Unexpected disconnect. So it'll be the server just closes the socket for some reason. Yeah, we'll code those eventually. I just want to leave these as placeholders so I don't forget. Right now you're working on a suite of YouTube videos and paired blog posts. Oh, cool. Working through your computer science curriculum, right on. Main interest in systems applications that efficiently integrate. So you're on the right path, I think, because that's a really hot topic now. That's awesome. If I was studying computers and data and applications right now, I'd definitely get into machine learning because that's where all the good jobs are now. Tough to advance in your interest when you're busy with discrete math. Isn't that true about being in college in general? It's tough to do much else besides your curriculum, right? Okay, log in failure to connect. Yeah, let me collapse these for now. Fantastic book recommendations, awesome. Well, feel free to give shout outs for anything. I'll write them down. Check them out later. Other people viewing might be interested too. Let's see. Yeah, the log into chat. We need to have the server actually send the message of the day. So what we'll do is we'll wait right in between here, we'll have the mock. I know what we'll do. We'll have the mock server wait until it receives. So await. I don't know. Await nickname. That's the second thing that's sent, right? The procedure is password, then nickname, and then we're supposed to do our bit. So we'll wait for that and expect that it happens in time, and then we will have mock server send. Okay, send is what the client calls to send something, so we need the other direction. It would be receive. Or what if we just qualify it? Return to client. And then we'll put in a message of the day. So tmi.twitch.tv. Actually what we'll do is literally copy exactly that. That's CRL. Actually, it'd be better to just add that, right? And the content of this second message, right? Does it really have that in the real messages? I forget. Hold on, let me check. Let me do this off screen too for a second. I had a recording of a real chat log with Twitch. I wanted to actually look at it, but I need to make sure, double check. My personal info is not in it. Okay, let me fully, because I'm a paranoid, let me fully obscure my token. Okay, yeah, so this is an example of an actual test I did, and I used an IRC client. I think it was HexChat. It sends a bunch of extra stuff, which we're not going to deal with quite yet, but I wanted to make sure that, yeah, this is indeed the message of the day. So, and this is the IRC client does the right thing. It does some extra stuff, which we'll handle later. And yeah, that's the message of the day, right? So it does end with this greater than sign. I wanted to make sure about that. Okay. Go back to Visual Studio. I need to terminate that line. All right. This needs a plus, doesn't it? Oh. Oh, and by the way, when you see that overlay, it's because it used to be that my dog would bark when people would come by the door. Most often now it's I have to mute because I'm talking to someone in the house. So that's what that is for. Semi-technical updated book by John D. Kelleher. It's about 250 pages long. It concisely covers the current climate methods, models, methodology, and ethical issues in semi-technical form. Okay, cool. There's a name to Google. So, MIT Press Essential Knowledge Series. I am gonna say later take a look at book recommendation. Hope you don't mind that I'm writing this down. If you do mind, I'll remove it. Just I want to remember that so I can look it up later. Okay. So we are going to do the right thing in our test now. We are awaiting the nickname, and then we're going to return the message of the day, because we're going to expect that we need to do that in order for the client to say yes, successful login. In fact, we're going to need to do that in another place, right? We have this login helper. It has the same kind of thing where there's a wait for it to log in, but it won't actually succeed to log in unless we send this message of the day. The helper will expect it is not actually doing a test, so we can ignore the test result there. Okay, so we don't have a wait nickname, we don't have return to client yet. We need to add that. Data science part? Oh, okay. Thank you very much. Although I wonder if that would be probably good enough to like get to that. But yeah, that's complete now. Thank you, thank you. So we're gonna make an await nickname and a return to client. All right. Where would await probably go? Well, let's put it at the beginning. And didn't we have a wait here? Oh, we don't have anything to wait for. Okay, so we have to have a the usual suspects when we're actually waiting for something is a condition variable, I mean, and then a mutex, and then the thing that will be protected by the mutex, which will be the actually it's this nickname offered. We'll use that, and then wait for. We'll just copy this and reuse that code here. So we will wait for, we're going to just capture our object's entire state, and then we'll wait until not nickname offered empty. We just have to make sure that when the nickname is offered, we do two things. When it's, I mean, not when it's gotten, but when it's set. Right here. So we will do two things. We will get a lock, and here we can use the slightly lighter weight lock guard because we don't need to unlock explicitly. While we have the lock, we'll set this thing that we're waiting on, and then we'll notify one on the wake condition. Then while one thread is waiting, the other thread will wake it up here when it's actually received. Unless too much time elapses, and then we return false. So actually we need not just to ignore the wait, we need to return the result of the wait. Okay. And we need return to client. I think I'll put it down here because it's, I kind of view this as, this is during the connection process, and this is after the connection process, and then this is like the third step where we're actually communicating. So it'll be return to client message. So we need a way to communicate back to our client. We don't have a way to do that yet. Gotta head out? Okay, well thanks for stopping by. Oh, thank you for the bits. So nice of you. Gonna watch this documentary. Okay. I'll try not to disappoint you. And looking forward to the machine learning. See ya. Okay. I have in real life viewer now behind me watching me, by the way. Okay. So await nickname, and then yeah, we're gonna have the return to client. And the problem is when the client connects, where is that shown? In these methods, it's not actually giving us any way to talk back, so we need to add that. So I think the way I'll do it is this connection class will have a couple types. Actually, they're all public. Everything's public in an interface. So this is the type of function to call whenever a message is received from the Twitch server. And then it'll have an argument, message. This is the message received from the Twitch server. Okay, and then it will be void, it's a type, right? So type def standard function. The standard function is in functional, so we need to declare that. And then I know we're going to use string, so we should include string as well. While we're at it, I should review these other methods. Oh yeah, see, we were already using string, and I had forgotten to include string. So a good thing we have that now. Okay, returns nothing. It'll take a string message, and we'll call that message received delegate. Okay, now we can make a method to set it. So virtual void set message received delegate. It'll be kind of like what we saw in messaging. It had these, so I'm going to kind of duplicate its comment. All right. I'm going to copy that. Whoops. I did Alt-Tab instead of Control-Tab. This method is called to set up a callback to happen when, whenever, because it's going to be more than once, any message is received from the Twitch server for the user agent. And copy, paste, and then this text here goes here. All right, and I need to make sure I forgot to make that a pure virtual. This is an interface. All of its methods need to be pure virtual because our messaging class will override it. Oh, wait a minute. No, it wasn't messaging. Oh, hold on. I'll be right back. Someone's at the door. False alarm. It was just someone walking by. Okay. Yeah, it was not messaging. It's connection. So the only connection implementation we had now is on our unit test. So that's here. And I put it right before connect. So that's right here. Override. So we'll just store it. And this way. Because I plan to just copy that and paste it here. You have to say this arrow because otherwise it's just going to assign it to itself, and we want to say no, we want our property name that happens to be named the same as our variable. You can do that because this is unambiguous. It's the property. Where this, I think the precedence is it uses the argument, even though that's a property of the class that the method is on. Anyway, we will set it, and then we're going to want to call it from this return to client, right? And only if they've set it. So if message received delegate is not null, then we can call it, right? So we can say message received delegate, and then just give it the message. Okay. I'm blaming the dog so much with that mute thing. I kind of feel bad for my dog. It's not her fault. She's not the one barking. It's just me turning around to talk to someone. All right. An interesting sound behind me. Anyway, I think the test is all set up now. Oh, wait a minute. No, it's not. Oh, you know it is. We're doing that, right? So let's try it out. So it should succeed. Oh no, we haven't written the code yet. What will it do actually? The test might be underspecified. Yeah, see, it's passing when it shouldn't. Because it's getting logged in right away. I think what we want to do is before we assert true that it logs in, we want to expect we can say expect. The difference between expect and assert, by the way, is an assert will stop if it fails. The reason why I favor expect because you get more information. But here I use true because if it didn't log in, it's sort of useless to check all this other stuff. Because those are set after the login is true. Okay. Yes, so I was going to change that to an expect false. So that'll make it fail because it'll actually log in too quickly before we send the message of the day. Hey there, Dank Dante. Making a Twitch bot, yep. I'm not exactly a masochist. I'm more of a reinventing of the wheel guy. And you might be able to tell that from, if you look at my notebook from the link below. I started off my stream by, well, that's not a very good explanation. Sorry. Maybe in the overview. My objective with my stream was to make my own web server and service framework written from scratch. So basically it's reinventing the wheel because, you know, there's already web servers and service frameworks out there. Why would you write your own, right? I'm doing it mostly because it's fun and I'm getting a lot of experience writing low-level stuff. I got a lot of experience in other places writing low-level code, so to each his own, right? So yeah. Also, the Twitch bot is not going to be as hard as a web server, so also it's sort of my opportunity to show people like what you need to do, where to go if you're going to do something with Twitch, or if you want to just understand how it's done, even if you didn't reinvent the wheel. Like if you go to their developer guide, and where was it? In the getting started, right? They talk about using this tmi.js. So if you're like me and you're inquisitive, like you wanted to know how that works, that's what I'm basically showing on stream, only it's in C++, not JavaScript. But even if you weren't inquisitive, if you just wanted to know like what's involved with like how you'd use that, what they have you walking through is basically what I'm doing, only I'm doing a little bit more, like I'm digging all the way into TMI, not just using it. So yeah. Yeah, I like to learn things by diving deeply. Like if you watch me, or if you watched me before, I like to get into the RFCs, right, from the IETF that actually define things. I know, I find that interesting. So, okay, I lost my place for a second there, sorry. Right, I had just built that and I expect it to fail because our code logs in too quickly. So there. We logged in when we expected it not yet to be logged in because we wanted to wait until we've sent the message of the day back. So now we've written the test, and now we're going to write the code. Test-driven development. So here we go. Right now we're assuming we're logged in as soon as we send the nickname. So instead we kind of got to wait. We're going to remove this. We got to wait until we receive back the message of the day. And I guess we'll do it naively at first. We will just implement... Where was it? Oh, we were going to set a delegate, right? So when we make this connection, we'll set a delegate. Set message received delegate, right? And we'll just bind to this, and we'll say the message. Actually, we don't even need to make a lambda function. We can just use bind. So bind, it's going to be impl, and we'll just call it message received. Arguments this, and the standard placeholders 1 for the message, right? So before they had lambda expressions in C++, this is how you'd always have to do it, and I still kind of like to do it when there's a one-to-one mapping between a function type, parameter, and an actual method, just because I don't have to repeat the type of the argument. I can just say, well, whatever that first argument was, just pass it in. But it is a little bit gross. So the alternative for a lambda would look like this. So you be the judge. Which one looks better? It would be capture this, and then you have to re-specify at least that much of the argument, and then you would be calling message received with message. So it's sort of maybe subjective which one's nicer. I have a friend who hates this syntax because he's not used to lambda expressions in C++, and he'd actually be more comfortable with this because he knows, okay, and that needs to be like that, by the way. He knows that, okay, that's a standard library thing, and bind is a pretty well-known term, which means you take something like a function that doesn't have any context, and you apply a context to it. So this is the context. This is the object we're going to call, and this is the argument. So that's bind, right? So he'd be more comfortable with that. I don't like it so much because, well, this is sort of a longer thing to say. You can make it shorter by saying using standard placeholders. I mean, it gets all subjective. I'm going to go with bind this time because to me it looks a little bit nicer. So we need to define that. And where will I put that? How about up here? So we'll have to have the same prototype as the function type, and pretty much I can steal the documentation as well. Where was that? That was on connection, yeah, here. So we're going to steal that documentation, just fix it up a little bit. This message it's called whenever any message is received from the Twitch server for the user agent, and then instead of the message received, oh, hold on, I needed the documentation for this type actually. This guy. Message. This is the message received. Okay. So now you can see the bind, where was it? Right here. No longer red squiggly. We're setting up a function to be called whenever we receive a message. And so here's our entry point when we get the message of the day. So we just need to interpret it. And I think what I'll do, so I just wrote it a little bit ago, I'm kind of going to steal from my test fixture in the send here. We did a little bit of logic where we had a buffer and we just added the message to the end, and then we parse off lines first, like that. So let's just steal that. And we need to then have this as a variable. And I'll have a formal documentation for it because this is the real code. This is essentially just a buffer to receive raw characters from the Twitch server until a complete line has been received and removed from this buffer and handled appropriately. Because we're always going to handle all our input appropriately, right? We're all responsible machines. So we add the message to the data receipt. We find the next end of line. If we can't find it, we haven't received the full line yet, so we return. And here's where you might want to pause and consider if we're talking to an evil server that might give us a ton of data, maybe gigabytes of data, and never have an end of line, we could end up blowing our memory. The worst thing that could happen though in this case is our client program will crash because it ran out of memory. I'm okay with that. And besides, I don't think Twitch server is evil. We'll probably find a just return. We might blow up our memory by making the string too big, but that's as bad as it'll be. So when we do find an end of line, we will extract it. Oh, and I forgot the line that removes, basically collects the leftovers, right? So back into the buffer, we put the substring beginning with the first character after the line end, including the terminator. So actually I'm going to do the right thing and make that itself a function called, how do we want to call this? We'll call it return a string. I don't know. Actually, it needs to be two functions, I think, because this part actually might get more than one line. So we'll have to repeat this until it returns false. So, okay, so we'll make a function for this part of it. So it'll be get next line. And since we already put it into data received, it's a member variable. We don't need to have any parameters. Say this method extracts the next line received from the Twitch server. And then we say the next line received from the Twitch server is returned. Only problem is, what if we received an empty line? Okay, so maybe what I'll do instead of return is we'll have a output parameter. Because I want to reserve the return value to mean whether or not we got a complete line. Okay, so this, we'll say this is where to store the next line received from the Twitch server, period. And the return value will be an indication of whether or not a complete line was extracted as returned. Because the idea is we're going to loop until this does return false. So by reference, not const, and we need to give it a name, line, I guess. We'll be calling it in a loop. So we're going to extract that method right now. So right here. Oops. Finger slip. I turned on numlock for a second. Okay, line end, return false. And then here we can store it in line and then return true, right? And then here we'll have line, string line, and then we'll have while get next line, line, and then we can interpret it. So how are we going to interpret the message of the day? That was in this guide. This is sort of a loose implementation, like a naive implementation. If I was doing it like waterfall style, like all of the code up front, I would be doing it literally from what like the standards say and not really just looking at the guide. But I'm doing an iterative approach here. I'll start with a naive implementation saying, well, this is the only thing we'll receive. And then later, as we'll see, because I kind of cheated and did some research up front, later we'll see, where's my other window, that a real session looks like this, and that we not just are going to look for this message of the day, we're also going to have this capability exchange that we need to interact with. So we're gonna start with an implementation that just follows the Twitch guide, naively assuming there is nothing else to wait for, and then we'll be modifying it later to actually do this extra stuff that you do want to do this. And the guide does go into that. It's just, unfortunately, when they give this example, it's not a complete example. But on the other hand, it's better to start simpler and say this is a successful connection, and then say, oh yeah, by the way, there was extra stuff, but we didn't want to tell you at first because it would be too confusing. Anyway, we're going to be waiting until, and here's where the IRC comes in handy. These codes mean something special. These 3 numbered codes are what the machine uses to interpret the kind of message. So if you actually go in the standard and search for that, 372 means the message of the day, and 376 is the end of the message of the day. So if we were to give the human user of our code the message of the day, we would do so by accumulating all of these strings that have 372 in front, and then when we get to 376, we know we've reached the end, and then we would give that back to the user. We don't have that requirement now, so I'm just going to use it to see, basically, not to see, but to determine that when we receive 376, we're connected because we've just received the complete message of the day, right? So we're going to basically need to parse this. If I understand this right, this is a prefix if it's the first character, and then after that, you have arguments that have space delimited until you receive one that has a colon, and then the rest of the line is the last argument. That's my interpretation of reading through the RFCs earlier. And I kind of leave it up to the, rather than explain that really deeply, I leave it up to you if you want to research that. But take my word for it that what we want to do is split the string by spaces initially, unless we hit one that has a colon, with the exception of the first character. So we're going to need some kind of state machine to break the line up into arguments, and then it's going to be the second argument, or really I think it's the first argument, not counting the prefixed one, that we want to look for the numeric code. Actually, I'm not, now I'm thinking this might be wrong about this part. Let me search this. If I remember right, let me zoom out a little bit. They talk about message format here. Okay, it is called a prefix. The prefix is optional, right? The prefix optional, the command parameters. And I think it says the command is either an IRC command or a 3-digit number. And it's going to be 3-digit numbers for the message of the day. So, yeah, prefix optional. So we might not get that prefix. We need to be prepared to handle that. Maybe we want this get next line to do all that parsing for us. So in that case, in that sense, we're going to have like a structure. Let's just right now, well, not here. Let me think about this. This is our implementation, so we can put it in our anonymous namespace. We're going to make a structure of what we want parsed out of every line. So what are we going to call it? Message line. So first I want to know if there's a prefix. And can a prefix be empty string? I'm not sure. Must be there. There's no gap between the colon and the prefix. Yeah, but can a prefix be just a colon and nothing else? I don't think so. Oh, here's the literal syntax. Okay, so prefix, the server name or a nick, and those are never empty, right? Okay, so if prefix is empty string, then there is no prefix. And then we have a command as string. How about, no, we'll just have a command. Actually, you know what I want is, we have the command, and it's a command string, and then we kind of want it to also, if it is a 3-digit code, get that 3-digit code out. Oh wait, no, we don't need to. We can literally compare with this string 372 and 376, right? So just command, and then we're going to have a vector of arguments. Okay, when it does that, it doesn't know what vector means, probably because I did not include the header vector. Vector. You can tell I'm pretty dependent on IntelliSense. I think that's okay these days. It's pretty much expected people will have editors that help them out to remember to do things or to catch typos or whatnot. Okay, parameters. And we're going to say, I'll terminate that first. This contains all the information parsed from a single message line from, actually it's from, this is, we're not implementing Twitch server, we're just implementing the client. So we'll say it's from the Twitch server, right? And then if this is not an empty string, the message included a prefix. Included a prefix which is stored here without the leading colon character. Because that's, I consider that part of the parsing. In fact, it's like if you were to look at this as a literal syntax, this is sort of just part of the wrapper. And when we unwrap the message into the structure, kind of expect the prefix to be here separate from the colon. So prefix command parameters, right? Space control, the character return line feed, that's all the wrapper. So we're not putting the wrapper in here. It's an unwrapped message line. Just the prefix if there is one. This is the command string in. This is the command portion of the message, which may be a 3-digit code or an IRC command name. Okay, and these are the parameters provided in the message. Parameters, if any, because it can be empty. All right, now that we have that message line, I'm going to use that, or get line, and we're going to just replace message line with that, right? So we'll call this the raw line. Okay, and we don't really care what its type is. It's going to be string, but I like to use auto. And substring always returns string, so we know it's a string. Yeah, so let's break this up. This part is extract the next line. And this is, well, we'll say remove the line from the buffer. And this one will be unwrap, or not. I don't want to use the word wrap, because wrap could mean like folding a line into multiple lines. Instead, it's unpack the message from the line. I'm wondering if I want to say get next message line to be unambiguous. I'll say next raw line. Yeah, let's do that. The next message line. So we have two terms, two local context terms here. Raw line is just a string. Message line is the unpacked message. Unpack the message from the raw line. Maybe we just want to call it message. Then I don't have to say raw. Okay, let's do that. Extracts the next message received from the Twitch server. Yeah, I like that better. So we'll just call it message. A complete message. Yeah, okay, good. I like that. We just need to, up here, rename that. Okay. That'll actually work if, for some reason, the protocol allowed to have multiple lines in a single message. Oh, went too far. Okay. Okay, get the next raw line. I'll go just say line. Remove the line from the buffer. Unpack the message from the line. Okay, so there I'm inclined to use a state machine. So this is what generic state machine looks like. We have a state, and then we have a while loop of some kind. And we'll have the end state be 1, because why not? And then we will have a switch on the state. And then return, or we'll be optimistic that it will succeed. And if we fail at some point, we'll just return false, early out. So let's see. Well, it's not 0. So the states will be 0. Actually, you know what I can do? I can. This is a little bit more formal than I want, where there's a definite end state. But I'm inclined to shortcut it and just have an infinite loop, and then just to have an early break if we for the end state. That work? Oh, wait a minute. there's a second condition we want to stop. It's if we exhaust our data. Yeah, so never mind. In addition to the state, we need to have more context. It's our current offset. So size t offset. So our we have two exit conditions. We can run out of data. So that I'm going to use that for the while loop. So while offset is less than line length. What we need though after here is if state is not equal to the correct termination state, then we return false, which we can then fold these together. We can just say return state equal 1 is the valid end state. So let's document this. So state 0 is let me think about this. First character of line, because it could be, maybe I should put this in the comment. First character of the line. It could be that, which signals a prefix, or it's the first character of the command, right? So let's check that. If line offset is colon, it's one thing, otherwise it's another, right? So here what we'll say is we move to state 2, and 2 and I think what I'm going to do is I'm going to advance the offset before we loop back up. Otherwise, we'll be in an infinite loop of unfortunate circumstances. So 2 is prefix. It's a character in the prefix, and it'll be as long as we don't see a space. Right? If we see a space, then we're done with the prefix, and we're going to then expect the next character to be the first character of the command. So we'll have a state 3, which is command. Oh, and there needs to be a first character, because we don't allow an empty command either. First character. Okay, oh, let me make sure that. Oh, I already checked this, didn't I? That you can have multiple spaces, right? This says single space, but there's somewhere else here that it said you should accept multiple spaces. Where did it say that? Blah, blah, blah. One or more. Here we go. It's weird. They say or more here, but in their syntax, they don't, because they don't really say that. Maybe that's what they're saying here. With this BNF representation, I'm not sure what this means, but maybe they mean 1 and possibly more. Okay, well anyway, we'll have to take account for that. So if the line offset is not equal to space, because if it is, we'll just stay in state 3, right? 4, and then 4 will be command. So it's going to look kind of like prefix. Command. And that will be, after the command, we go to arguments. And then arguments, the same kind of thing. 5, we'll have a 5, and we'll have a 6 first character of parameter, right? And then if we don't see a space, we're on to the rest of the parameter. Actually, we need a special case here, right? Because the last parameter can have, oh, and that needs to be, oh, let's put it first. So if it's, specifically if it's a colon, it's the last parameter, right? So I'll have a special state for that. Otherwise, if it's not a space, then go to state 6. Otherwise, it's space, so we just repeat, right? 6 is it's a parameter and not last. or last having no spaces, right? And so there, if we see a space, it's the indication we're going to have another parameter, right? Otherwise, did I do this right? Otherwise, we need to accumulate the next character. Actually, we don't need an else. Yeah, we do need else. But we need a 7 as well. 7 is last parameter. May include spaces, right? So there, we actually stay in that state for every character, and we just that's an end state. So 7 is a valid end state. So we need to list our valid end states here. 1 was a valid end state as well, right? Oh, I didn't have a 1. Oh, I was thinking I was going to reserve state 1 for end, but we actually don't know when we get to there unless we run out of characters. So we'll just subtract 1 from everything here to collapse that. 6, 5, 5, 4. So one potential improvement, I'm being kind of lazy by using numbers, but I could use symbolic names here if I had an enum class. I might want to do that. Otherwise, I risk having bugs here with numbers being wrong. Okay, so what are the valid end states? Can we end in state 0? I suppose we could. Yeah, okay, so oh, you know we're missing something here? I just realized. We are not doing this trim thing. Oh. Can a line begin with a space? Let me see. I don't think they can. Oh, and that reminds me of something else. Yeah, okay, so this return value is if it's not if a complete message was extracted, it's if a complete line was extracted. But we don't know if the message is valid unless I know we'll have that documented here. This is the command portion of the message made. If it's empty, the message was invalid or there was no message. So we'll have like a special condition for that. So then what we can do here is we say if we're not in any valid end state, then message dot command clear to indicate that, but we always want to return true here because we were kind of reserved false to be up here if we couldn't find the end of the line. The reason for that is I kind of we want to eat invalid messages and not get stuck not attempting to get the next message just because we didn't get a valid one. So this will mean that we need to stop processing because we literally have not enough characters. So if we do have enough characters, we'll always return true, but if the line that we read doesn't conform to the protocol, we'll just clear the command. It'll be just an invalid. And we might also want to log an error. If we had a logging facility, we would put it here to log that it was an invalid message. Okay, so again, the invalid end states. Yeah, 0. Maybe we'll just list them explicitly. So 0 is invalid, end state. 1 is also invalid because we need to get, oh no, yeah, we need to get at least a command, right? So 1 is invalid. 2 is, yeah, we're still waiting for the first character. Command has to have at least one character. 3 is if we were reading a command and then we hit the end of the line. That's valid because a command just could not, might not have any parameters at all. For 4, we're actually expecting a parameter, right? Because we see a space after a command. Actually, I'm thinking we will allow 4. That'll handle the case where there's extraneous space characters. Yeah, we'll allow 4 as valid end state. 5. Right, that's if the line ends, if we're in state 5 at the end, that means the last character was part of a parameter. And 6 too, so those are all valid end states. So these are the invalid end states, we'll clear the message. Now we actually have to just put stuff in the message. So, right, when we know that there's a prefix, we'll not only go to state 1, but we're going to, well, actually we should probably just clear the message's prefix to begin with. Actually, we should, let's do this trick. We'll call the message constructor to get a default message because, oh, that's interesting. Google Test has their own class called message, so it went to the wrong class. Yeah, we want to go to the unnamed message up here. Standard string has a default constructor, and so does standard vector. And so by calling the message constructor explicitly, we'll clear all of these things, which is what I want. I want the prefix cleared so that in state 1, what we'll do is in this else, we'll just say message.prefix plus equal line offset. We're just going to tack on characters. And then first character or command, right? Oh, hold on. And there's no else here. In addition to going to state 3, we will, it's going to be empty to start, so I could do equals, but plus equals also works. Command will start out empty, it'll be the first character, and then here it's in the else. If it's not a space, we add it here, right? And then, okay, when we get to parameter though, right, so it's the first character. If either of these is true, we're going to make a new parameter, right? So message.parameters push back empty string in that case. In this case, it actually is the first character, so we'll just take the string formed from, well, string form substring from offset with 1 character, right? And then space means we're done with that parameter, we go to the next one. Otherwise, we're going to build off of the last parameter, right? So parameters.back dot just plus equals line offset. And then same thing in state 6. Only this can have like anything in it, colon, a space if you want, or other characters. So this might not be the strictest, but this should work. We need to, this one we wanted to, oh, we already have message. Let me rename this to message fragment. How about line? It's really the text, raw text. This is the raw text received from the, yeah, because I want to reuse message, so it'll be message. And I renamed this, didn't I? Let's get next message. So while we're getting messages, if message.command empty, then it's invalid message, and we can just continue, right? If it's not empty, then here's where we want to interpret these codes, right? So I think for now, we're not going to do anything with the message of the day. We'll just wait until we see code 376, and then we'll say, hey, we're logged in. So if message.command equals 376, and this is a bit magical, so maybe I will put a comment saying a copy of this 376. So that's REPL end of message day. RFC 1459. Is that enough? I guess if someone wanted to know more, they would just Google search it or search it within the RFC. End of message of the day. Okay. Now, here's where we're going to finally put the code we removed before. So it was if logged in delegate not equal to null pointer, then call it, right? I do want to make sure we don't call it twice. The server, it'll end up calling it again if the server does a bad thing and sends us 2 message of the days. Actually, that might not be bad. If the message of the day changes, we might get it again. In fact, we should have a test for that. Let's throw in a test. Let's put that in here. Right here, log extra message of the day while already logged in. And it'll take this, let me think about this. Yeah, one where we set a logged in delegate. Not that one. One of these? Yeah, run one of these. Yeah. So it'll be login normally for test begins, and then here we'll have the server send another message of the day, and make sure we don't receive an extra logged in callback, right? So we set it. We don't need to do this stuff. We don't need to do that. Where was the... Here it is. We'll just have it send it again. And then you'll copy this condition. So like that. So we'll actually have it send it again, but we'll expect false. In other words, we don't expect this delegate to be called because we're already logged in. We already logged in up here. Okay, so there, yeah, I wanted to throw in that test. And to make it, should I make it pass right away? Or should I, I'll keep it like this and then the test should fail, but the other test should pass now again. This one that failed before, the login to chat should pass, and the new one I made should fail. Yeah, login to chat passes now, but this one fails, and that's, to fix that we need some state. So we'll have an if logged in, or actually if not logged in, then we're logged in, right? And if we're already logged in, it'll just ignore that command. So we just need to add that to our state right here. So this flag indicates whether or not the client has finished logging into the Twitch server. Right now we've received the message of the day from the server. All right. Now, hopefully, the test I added that failed will now succeed. Cool. Awesomeness. So, I like to make a new commit whenever we get to the point where we've added some new tests, which implies a new feature or a change to a feature, and then we get it to pass. So it's like a nice milestone. So let's go and do that check-in now. So we'll see it in the form of new things added to the test. So this whole test about don't expect a message of the day, and this change in expectation. Now let's do this in two separate commits. So first it'll be this change in expectation that the client should expect to receive the message of the day before logging in. So that'll be commit 1. Right, so that was a necessary change. That, actually I'm just going to default to all of these things. Let's just default to all of them we're going to commit and then remove the ones we don't want in the first commit. That'll be like this new test here. This will be unstage. This extra message of the day, I kind of want that to be a separate check-in. So that was comprised of this extra logged in flag, right? Let me unstage these lines, and then remove that logic about these ones, right? So unstage these lines. The indentation won't be right, but what's worse, the indentation being wrong or having two different things in the same commit? I like it this way. So it'll be, this first commit will be change in expectation. It's essentially there. So messaging. Expect client to wait for message of the day before login is complete. Right? And then the second commit is messaging. Extra message of the day from server should not trigger second or extra login callbacks. Right? Look at that, just barely kept it to 80 characters. Actually, I don't know if that's 80 characters or not. Cool, I've been streaming for 2 hours. Don't know if anyone's watching, but that's fine. I'm used to having no one watching. Maybe more people will watch once I get this actually to run with the real server. We have enough in here now, and we can actually start testing the receive stuff down here, right? Or I can handle these failures with no message, unexpected disconnect. So the no message one, I think, will be a timeout kind of failure where the client will diligently wait for the server up to a certain point where it will give up and then declare that the login failed. This one is if it logged in, but then the connection's dropped before the user asks to disconnect. So I can work on any, and this third one is if we just receive a chat message. So I can work on any of these now. Actually, or I can also work on that as well. And these ones are all filled in, right? Yeah. Okay. I'm inclined to do them in order. So the first one will be that we don't receive a message of the day. So let's first copy from login. So it'll be like a login scenario, only we will not send the message of the day. Okie doke. Yeah, so the difference here will be we will, don't need to await the nickname. We will expect, right, we'll leave that in. We'll just not do this stuff at all. Oh, hold on. No, we're going to change this. Oh, we're really just going to add. Okay, we're going to combine log in and log out because we don't want to log in and we do want to log out. So logged in delegate and logged out delegate. We'll have both. All right. So we will expect we don't get a log in, but we do. Actually, let's change it to that we do expect a log out. And then we can simplify this other one. We can expect false so we don't get a log in. We get a log out eventually, but when we receive the logged out, we'll check that we never got a logged in. Like that. And then we don't need any of this stuff. This stuff doesn't happen. There we go. So we start the login process, and then this will basically wait and timeout. So we need to adjust this timeout a little bit. The technically correct thing would be to allow this class to be told what its timeout would be. It might have a default, and then the class wouldn't actually wait in real time. It would use some kind of time interface so that we can mock time and say time advance 5 seconds, and then we expect the log out, right? Do I want to go through all that effort now, or just cheese it and do a physical wait? Let me look and see. How difficult it would be to mock time. I did this before. System abstractions test, right? Connection test, I think. No. What would it be? Timekeeper? I think it was called Timekeeper. Yeah, okay, so here I had a mock time, I had a Timekeeper interface. I guess it's not really that big a deal. It's pretty simple. Only the underlying wait in the client is, that's a problem because it's waiting on a condition variable, right? It was, oh, it's not really waiting at all. Well, okay, it's waiting here, but it doesn't actually handle it in the worker, does it? It handles it directly here. Actually, that's a problem. I should fix that before I move on. I didn't make any changes since the last check-in, right? I did. Oh, okay, yeah. Well, that's okay. We'll keep that in there for now. I want to. Oh, wait. Actually, you know what I'm gonna do? I'm gonna stash that because I want to back up a little bit. And before we handle this no message of the day, I want to, instead of synchronously handling messages received, I think I want to have it something that the worker thread does. Yeah. So this is what I'll do. I will add a new action type called process messages received. And it'll say this: process all messages received from the server, Twitch server. And we'll just put the raw message in there. We'll just call it message process message received from server. Well, it could be multiple, right? Well, but we'll use this to kind of hold on to the raw text. So it will kind of look like this. We will have, does it make sense to have a lock guard here? I don't want there to be a deadlock. See, right now we're using the connection class while holding the mutex. I have a way to fix that. So we really are not protecting a whole lot with this mutex. We're really only protecting actions. So after we are done with dealing with actions there, we can do this. We can unlock it, unlock the lock, work with this copy we made of the action, because it's not on actions anymore, and then lock it again so that we can, because this wake worker is also protected by the mutex along with stop worker and actions again. So now we're not locking the mutex when we are using the connection. So yeah, so in the callback it's safe to lock it temporarily just to do this much. So we'll do that. So we're gonna put this here and move this into a new case. And actually I'm kind of thinking that these cases need to be broken out into their own methods, but for now we'll just put it here. It's maybe a step back in terms of readability, but that's okay. So instead of raw text, it's what's it? Action, next action dot message, and then we do that. Yes. Cool. I think we're good. This could end up re-entering our class, which is another reason that it's good that we're not holding the mutex, because that could grab the mutex, right, if we re-enter and call logout. So yeah, I like this better. So we just need to make sure that this turns into a well, it already is, but we're going to repurpose the copy of the code. Instead of a logout, it's a process, and then this is the raw text, right? So this is a refactoring. Refactoring in test-driven development is you change the code and you do not change the tests. So if I go to here and do git status, it'll be only the source code and not the tests. And you're done refactoring when you've done the work that you intended and your tests still pass. Tests still pass, so we're good. We'll call this refactoring. So messaging refactor. What is this? Processing of receipt of text receipt from Twitch server. So there's two things actually I did here. So it used to be we synchronously handled received messages, right? So make handling of received messages asynchronous. Performed by the worker thread. And then the second thing that I did was we no longer, well, really, the reason why we're doing this is to avoid deadlocks by not holding mutex while performing actions in the worker thread. So now the scope of the mutex is nice and small. The only thing the mutex really protects is this actions, the stop worker, and the wake worker. The connection and all that other stuff, it's exclusively within the worker thread, actually, which means that we can move it to be a local variable now that I think about it. Yeah, nothing is going to be using that, right? Yeah, we can totally make that a local variable now. I'm going to do that. Just to reinforce that it's not protected by the mutex. We will take it and we will move it. I can say the same thing about data received as well, and about the logged in flag. That's good. So now it's clear that the only thing that the mutex protects are the things that are in the state, the object state, and then, okay, we're gonna have to pass it in to get next message, but that's fine. That's actually better because it doesn't rely on a side effect of knowing that. Question is, do I keep the documentation for these variables or not? I mean, I could. They're local variables now, though. Let me think about this. I will, but I will turn them into normal block comments, not doc comments. Because I don't intend them to be seen in printed documentation anymore. It's only if you're reading the code. Because they're not visible from outside the code anymore. They're local variables. That's why I'll do it that way. There we go. And then, yeah, for this get message, it needs to be given the data received. So that'll be not const, data received. And that's both in and out. And then say this, actually we have a documentation for it, right? Here we go. Yeah, I'm gonna allow the well, no. I'm trying to use this reformatting thing, but unfortunately it like collapses that, so it kind of interferes with my style. I posted a GitHub request for them to like give me an option to preserve that style, but I don't think anything's been done with it yet. Okay. And then we have to pass it in here. Cool. So one thing, like I was saying before, I could improve on here is I could make the bodies these cases actual functions. But I should, but I'm lazy. I'm feeling really lazy right now. Okay, so yeah, we're done refactoring, right? Refresh that. I pulled that in while I was looking at the changes. So that's the third thing that we did. So move state that doesn't need to be protected by the mutex so that they are local variables in the worker thread. How about it's not the worker thread really, they're local variables in the worker method. Okay. Cool. Push that, please. Refactoring done. So, back to this point. Yeah, do we want, oh right. Yeah, so the problem I was thinking I'm going to run into this is this failure because you don't receive a message of the day. The only way the client will know that there's no message of the day is if it times out. And right now there is no timeout in this wait. It just waits forever until some action happens. And so we need a way for an action to get generated or for us to time out the wait. And in order to know that, hey, we were still trying to log in, but we haven't logged in yet because we haven't received the message of the day. I need to think of the right way to do this. Probably what makes sense to me is when we're told to log in and we send all this stuff, we should note the time. And then I think we should periodically wake up and I guess what we'll do is we'll insert an action automatically. Yeah, I know what we'll do. We'll have an action called check for hold on, let me think about this. Yeah, we'll have, sorry, I'm indecisive. Right now, it'll sleep if there's no actions at all, but we kind of want is like an action that isn't complete, but we still need to wait. Oh, furthermore, what happens if we're waiting to log in and then the user says, I give up, log me out? Because right now, log out pushes the action log out to the back. So it'll basically wait for any pending action to complete and then log out. Actually, if you wanted it to be immediate, you wouldn't bother calling logout. You just destroy the class, right? So yeah, I suppose it will just make another action, and it'll be a special kind of action. So we'll call it awaiting, await, message of the day, I guess. Excuse me. Throat dry, must drink tea. Okay, so this will be a special kind of action that stays in the action queue at the front, or basically gets reinserted into the front, until we either time out or we, well, yeah, we'll explicitly pop it out, I think, if we receive the message of the day. Actually, that'll allow us to get rid of that logged in variable as well. So we'll say, it's not that the worker thread performs it. Let's change the documentation here. These are the types of actions which the messaging work class worker can perform or await. Well, no. We're performing something. What we're performing is a wait. Right. Wait for the server to provide the message of the day, completing the login process. Okay, but we're gonna need something special here because the wait won't wait unless we have, let's make a little marker here. Bool, wait. And by default, it'll be false, but we'll say, if this flag is, well, do we want a flag? Sure, if this flag is true, or this flag is set true, the worker should postpone processing. Well, hold on, not postpone. Well, no, we'll say, yeah, we'll continue. We'll have it postpone processing for a short period of time. Yeah, I'm going to use the same model that I did back in this chat room plugin. What I did is we had a timekeeper that would report the time, and then we could mock it and like say whatever time we wanted. And the actual code, the chat room plugin, it would do real-time waits, but very small ones, like 50 milliseconds. And every 50 milliseconds, it would poll the timekeeper. And in the real implementation, it would be the real-time clock. In the test framework, it would be a pretend clock. So here it'll be delay. Let's call it delay. And then if it's delay, we'll have a timed wait. Yeah, I like this. So let's define, well, no, we don't need to define it. I was going to say define the amount of time we delay. But it'll look like, we're going to modify our wait a little bit. It's going to look like this. We're going to wait for either action is empty. Well, hold on. No. Never mind. We'll be explicit about it. If not actions empty and actions.front delay, which we don't need a parentheses around, then we wait with the timeout. Otherwise, we'll wait forever. And here, what we'll do is we'll do await for. And we'll have a very short, like 50, I consider 50 pretty short, where we're going to just wait for stop worker. Hey there, Rally Monkey. Oh, and I missed a chat from Ali America. And he or she said, that's a lot of code. Yeah, a lot of code. Although, I typically think if we're under 800 lines, it's not too long. So we're still good. If we're at 471 lines, we're okay. Might be a lot, but we're still okay. So, Rally Monkey, you're asking, am I back to being an evening, nighttime streamer? Not exactly. I've moved from a scheduled streamer to a spur of the moment streamer. I'm streaming whenever I feel like it, not on a strict schedule. At least for now. So here we have two modes now. If there is a delayed action, we'll wait just for stop worker gets called, up to 50 milliseconds, and then process it. Otherwise, we're going to wait forever until either we have an action or we're told to stop. So now we can make an action for, actually we already defined it, right? Called, where is it? Await message of the day, right? So, actually where was await message? So it's between login and logout. Ligin. So between these two, right? So case action type, wait message of the day. So here it's going to be a little weird. We will basically check to see if it's timed out. If it hasn't timed out, we'll basically re-push the next action onto the action. So we need to do a lock, because we're modifying the actions thing again, and we'll do actions.push, but not to the back, we push it to the front, the next action. Basically redo. And that'll be if it hasn't timed out. The idea is that if we do receive this, we're going to replace this not logged in to just popping the next action. Because the next action should be an await message of the day, right? Actually, we can do a check for that. We can say if the command what I was thinking of doing is if the command is 376 and not actions dot end or empty and actions dot front dot type is action type await message of the day. But I'm thinking, is that true? I think that's not true. When we're going to receive the message of the day, we're going to receive it in this state. Okay, maybe it was not a good idea to have this delay thing in there. We'll do it differently. Let's do it differently. So put this back the way it was. Instead of this, we'll just remove this. I'm going to move this. This is now going to be on the same scope as the actions. So instead here, we'll have, actually, we'll make it a double, because we'll turn it into the time. So timeout. And if it's 0, it'll mean we're not waiting for something. If it's non-zero, it'll be the time according to the timekeeper, after which we'll time out what we're currently waiting for. So if this is non-zero, then the worker thread is waiting for something. What are we waiting for? Maybe we should have either a variable or a queue of things we're waiting for. Let me think about this. We could have multiple things that might time out. Actually, that makes me think of priority queue. Maybe we'll use priority queue. I hardly ever get to use that. Yeah, let's do priority queue. That'll be fun. So it's not going to be just a double. It's I need to look up in the manual what is priority queue declared in. Hello, velocity. C++, please. And priority queue is in, oh, it's in queue. Okay, never mind. So we just need a queue. Queue. All right, but we need to protect that with the mutex, right? Or do we? The worker is doing most of this stuff. Yeah, let's just make it part of the worker. So, worker. Here we go. Priority queue of timeout. How about timeout condition? Well, I don't know if I like that name. It's always going to be stuff we're waiting for. So like pending event. Well, maybe we'll keep it for now. Timeout condition. So these are timeout conditions. So, oh, I was going to use normal comments, not dot comments for these local variables. Okay, this holds onto any conditions the worker is awaiting, which might time out. And we'll just need to make one of these, like an action or a message. It's another kind of structure. I can get rid of this, can't I? This represents a condition the worker is awaiting, which might time out. I don't know if that's good grammar or not. I'm getting a little bit tired, but hopefully good enough for government work. So here's where I'm going to put the timeout value. So expiration. And do I need to, I don't really need to have a default, but I'm going to do it anyway. This is the time according to the timekeeper at which the condition will be considered as having timed out. actually, let's say at which the client will have considered the condition to have timed out. Oh, or the condition will I'm too nitpicky about the wording, aren't I? Maybe the original is better. I'll keep it like that, and then maybe we'll just use an action type. We'll just reuse that. This is the type of action which prompted the wait condition. That should be apparent. We'll just invent, if we need to, we'll invent action types representing different stages if it's a multi-stage wait. Yeah, I like that. Okay, so then what we can do is I'll get rid of this right here. We can say login, and then at this point we can say timeout condition type is action type login, timeout condition dot expiration, and here's where we need something we don't have yet. It will be like timekeeper get current time, and then we'll have, right now we'll keep it as a constant, but maybe later we'll have it configurable. It'll be login timeout milliseconds, or timeout seconds. Actually, we'll just make it a chrono value, that we don't need to specify it. Period. And when we use the timekeeper, it's probably prudent to lock. So, and we're going to need to lock anyway to put it into the timeout. Oh, no, we don't. We don't. We don't need to do any of this stuff. Yeah, we'll expect the timekeeper to be configured before we start the worker, right? Or before we try to log in. Actually, you know what we can do? We can be really smart about it. We'll say if if there's no timekeeper, it'll never time out. How about we do that? And then we'll just define this right now. Const duration. What? How does that work? We have to include chrono for that? Standard, I think it's actually standard chrono duration. Seconds. Actually, I don't fully understand this stuff. Maybe I should search this to make sure I'm doing this right, because I think I did this before after checking how to do it. Maybe not. Actually, you know what I did to find that out is I researched condition variable wait, and I looked at the prototype for the wait for. Where is it? Wait for condition. No. Nice. Okay, maybe I need to spell the whole thing. I don't know why, because I want that, and I want to search for wait for. I'm going to see how do they define this. 100 rep time. Okay, so okay. They use the same template arguments. Yeah, and if I want to be explicit about the template arguments, I can just use this, right? So, okay, so I can actually say this, right? What happens if I say milliseconds? Okay, yeah, it doesn't match, okay. Alright, I think that's all I need to do. Actually, can I just do that? That's even better, right? Okay, we'll do that. This is the... Oh, actually, what happens... Now I'm curious. What happens if I do that? That doesn't work. Okay, we'll stick with that. This is the amount of time, the maximum amount of time to wait for a Twitch server to provide the message of the day confirming a successful login before timing out. All right. Then we need timekeeper. So for that, we're going to need another interface. Yeah, let's do it right. So I think the way I had it specified before, it was in HTTP. Timekeeper. So I think we can just steal that. So I'm going to go to VS Code here. I'm going to go to HTTP, and we're just going to totally rip it off. So here's timekeeper, copy, and Twitch, include Twitch paste. We just need to go in here and replace this with Twitch. And actually, most of the places it's going to be lowercase. Except for 3 places. All right, this declares a Twitch timekeeper interface. I don't know why we had that include. We don't need that. We don't need functional or memory or even standard int, do we? This represents the timekeeping requirements of Twitch classes. To integrate Twitch into a larger program, implement this interface in terms of the actual client time. In terms of real time, So by the way, I should explain why I'm doing this and not just calling like get current time. I want to abstract the notion of time away so that I can, in my test framework, pretend that a lot of time, like over a second, elapses without making my test actually take a second to run. That's why I'm doing all this confangled stuff. So we're going to want to include that in the list of headers, just so that it shows up in the IDE timekeeper. And then from the build directory, cmake dot, and then hopefully it will show up in Visual Studio. Okay, it didn't. I've seen that happen before when the only change is a header file. Close Visual Studio and open it again, and it comes back. It should show up under Twitch headers. Here it is. So we need to make a mock of it. Similarly to how we do it here. So we'll just copy this code. And where is it? Messaging tests. Paste it here. Near our mock server, we'll have a mock timekeeper. This is a fake timekeeper used to test the messaging class. Okay, mock timekeeper, so it's Twitch timekeeper. And to get that, we need to include Twitch timekeeper. Right, so we're going to make one. Kind of how we're doing the server, only... Yeah, I think yeah, it's going to be a shared object, right? So mock timekeeper. To simulate real time when testing timeouts. Okay, and part of our setup for our fixture should be similarly to how we're setting the connection factory. We're going to set the timekeeper to mock timekeeper, and we need to declare that. So we'll put it near here. Set timekeeper. Timekeeper. Need to include timekeeper here. And copy paste documentation and fix it up. This method is used to provide the class with a means of polling the current time by means of polling the current, it's not the current time of day, it's really means of measuring time periods. Elapsed time periods. Okay, this is the object to use to measure elapsed time periods. All right. Implement that guy. So that goes pretty close to this guy. Steal documentation. Oh, wrong one. And I think we're good. Oh, that was a double and that was a chronoseconds. Oh yeah, yeah. I got confused. I was originally going to use this with a wait, but now I'm going to use it with the timekeeper. So this should be really timeout seconds, and we'll make it a double. So much for all that worrying I was doing over durations. So that's... I don't know, what's a reasonable amount of time we'd wait for the Twitch server to get back to you? Maybe like 5 seconds? And that's double. That's... You could use a const x for it. This is the amount of time. Well, okay, don't have to say in seconds because it's part of the name. All right. Okay, so I made up that object, and now I need to put it into our timeout conditions priority queue. Push. And then we need to modify our wait down here. So we're going to do it this way. If let me think about this. This I can put back over here. Because if we're told to stop or we get a new action, we kind of don't want to wait for the full 50 milliseconds. This is sort of arbitrary. It just has to be short enough so that it's not too much more than our timeout. So, yeah. So if we're going to do this if not timeout conditions empty. And then we just need to make sure we evaluate that. I think we'll do it here. If not timeout conditions empty, const auto, well actually, yeah, we can do const auto timeout condition equals timeout conditions front top. returns a reference, so we can also make it a reference. Or do we? Maybe I want to copy because then I can unlock, just like I'm doing with actions. And yeah. Actually, I can probably move that out. Yeah, I can move it out. Because we don't need to protect that with the mutex. Okay, so here's what we do. If timekeeper get current time is greater than or equal to timeout condition expiration, then we've timed out. So it's going to be another switch on action type, right? Switch on action type. And I guess by default, we'll just do nothing. Because we all, yeah, we'll just, actually it's not nothing. We'll at least pop it off. That's what we'll do. So timeout conditions pop. So here's the point where login will now time out. So what I want to do for a timeout, I just realized that I didn't write the test first, so oh well. We'll do the code first though. Then we'll write the test, and don't tell anybody I messed up in doing it in the wrong order. Okay, we want to do something similar to when an error happens, like this one right here, right? Connect failed. So here's what we'll do. So it timed out, so we call the logged out delegate. And logged in. Actually, does it really matter? Actually, we want to do same as what logout does, right? We want to do a disconnect. In fact, let's do all of this. So we'll make this a function. Void disconnect. I'll just put it all in there. Oh, wait a minute, I can't. Well, I can if I provide the connection and the message. Fair enough, right? So we'll do this. And this. Farewell. And then these become dots. This becomes farewell. And we'll say this method is called whenever the user agent disconnects from the Twitch server. And problem is, like, I'd like to say const here, but send is non-const. I think as long as we specify in, no, I do want to say in out because we could have side effects. So connection. In fact, we do have one big side effect, which is we disconnected, right? So this is the connection to disconnect. Farewell. This is the message to include in the quit command. The server, which is sent just before disconnecting. Right. So now we can call it from both places. We can say disconnect, and then we can actually say something, connection dot get, and then we can actually say something like timeout waiting for message of the day, right? How come I didn't like that? Really? Get returns a const? Oh, no, I don't use get. That's right. I use star. There we go. So, in the other place, log out, we will... Yep, we will just put in next action message for the farewell. I like that. Okay. Right. Okay, so I didn't explain why I'm using priority queue. The reason I'm going to use priority queue is if we have multiple things we're waiting for, priority queue will keep them sorted as long as we provide a sort predicate or a method, a way to order them. So that's convenient. Like if we start waiting for something that might take 30 seconds, and then we start waiting for something that'll take 5, and then we start waiting for something that takes 15, we're going to insert them in the order of 30, 5, 15, but then it'll get reordered to be 5, 15, 30, right? Like we want. That's what priority queue's job will be, so that the top here will always return the next thing that will expire, regardless of the order in which we pushed them. And then pop removes the next one. So the idea here is that if there are any timeout conditions, we're going to be polling the next one to timeout to see if that time has arrived, and when it has, we'll do something and then pop it off, and then we might go back to waiting forever, or we might still be polling if there's more things that might time out. Does that make sense? Good. I'll pretend that you guys said sure. The only requirement here, you'll see it when we try to compile, is that it won't like priority queue because there's no less than operator in timeout condition. So yeah, we have to make a method property, if I can spell correctly. We need to make a less than operator. So this method is used to sort timeout conditions by expiration time. And then there'll be one parameter, which is the right-hand side of the comparison. This is the other timeout condition to compare with this one. And then return, here's where I need to kind of, again, go to the manual for priority queue. I forget what it expects. It'll use the smallest element to appear at the top. So, using greater would make the smallest. Okay, so the largest element. So if the default is less, right? So less returns what? Okay, it'll return true if the left-hand side is less than right-hand side. This is I always have to read this carefully because yeah, priority queue, it's going to sort for largest. So the one that's always greater than the others. So in other words, not less than. So we want less than. Okay. This returns true if the other timeout condition will expire first. Let's see if I got that right. So it's bool operator less than const timeout condition right hand side and return expiration. So true if the other will expire first would be that it's greater than right hand side dot expiration, right? So is this going to order it correctly? So what we want is the smallest first. What priority queue will expect is a compare less and make the largest one first. So we want the smallest expiration to be first. So it's going to be backwards. So if, like, let's say expiration for this one is 0, it'll be false always, which means it'll appear less, which means, okay, I think I got it backwards then, right? No, greater, largest first. We want 0 to be larger than any. I think I got this right. So we want for the very first element for it to return false for less than, regardless, right? What it's comparing to. If it's 0, 0 is never going to be, yeah, so I think this is correct. It's inverted because the default is less, but then it sorts it largest first. Yeah, so I think that'll work. I mean, we'll be able to test that if we have 2 timeout conditions. Doesn't take const? What does it want? Oh, maybe I need to make it const as well. Yeah, there we go. Now it's happy. All right, and then let's make the test. Pretend I made the test first, okay? So that was this login failure, no message of the day. I was going to start with just a normal login. Log into chat, right? This guy. And what I was going to do, oh, I had already done, oh, that's right. I had stashed that change. So let's get it back from the stash. Here. Oh, what changed in the tests? Okay, that should be fine. But I want to get stash pop. I want to get the change I was working on in the unit test first. Oh, I have to stash those too? Shoot. Okay, I'm gonna look this up really quick, even though I don't really like to do research while streaming, but just really quick, how do you merge stash into working, merge stash with unstaged changes? Actually, that makes me think maybe the way I do this is I stage it and then pop the stash. Let's see if that works. Stage the test change and then stash pop. Okay, that worked. So that's my answer. You stage it and then stash pop, and then I guess unstage will, yeah, will get me both the changes I've been working on before from the stash and then the new changes. Good. So here's what I was working on before. We set both the logged in and the logged out delegate. We tell it to start logging in. And then here's where I needed to have the mock timekeeper. Current time, we'll set it to 5 seconds, right? That's the timeout period. Now we expect to get a logged out. Actually, you know what we can do is we can do this twice. We can assert false. We can see that it doesn't time out, and then we move the timeout period, and now it does time out. Hold on a sec. Yeah, someone came home, and so the dog goes berserk. But hey, look at that. We passed our test. So just as a sanity check, let me make it 4.9, and that should fail our test because it won't time out then. See there, it did not time out. So cool, our timeout works. So let's go ahead and stage that, or confirm that it works again, and then push the change. And see, now I wanted to point out that we have a 5-second timeout, but the test can complete in less than a second because we're simulating that 5-second period elapsing. Okay. Check it in. Yeah, I probably need to take a break to eat dinner soon. Here, we're added timekeeper. Added timekeeper. Okay, and now add the ability to set the timekeeper. Add the log, the timeout stuff. Timekeeper. We had to implement disconnect at some point. Oh, no, that was refactored. We refactored out the quit stuff. Oh, we should add that to our test. We should expect that to be sent and the disconnect to be called when the logout happens. Priority queue, yep. And then here's the handling of timeouts. And then here's where we set up the timeout to happen. And there's the, we refactored that out to be a function. And then here's where we will go into a polling mode when there's a timeout pending. Yeah, it's unfortunate that we have to do polling because the timekeeper is not something we can wait on. Although I guess we could, if we wanted to, we could take this timekeeper and have like add another method called wait. The problem is that if while we're waiting, we inserted another timeout period, like into a priority queue, it might be a little awkward unless we had a third method called like wake up or change timeout period or something. So I think right for now, I'll keep the timekeeper simple at the expense of we're going to do polling. It is limited to 20 frames per second, so to speak. So it'll wake up a lot, but no more than 20 times in a second. So the CPU usage should be pretty minimal because all it'll do is it'll wake up. It's probably better to show it here. It'll wake up and then look at the current expiration. See, it'll be polling the timekeeper. See, it's not expired yet. And then fall back out all the way back to the wait again. So it won't really do much more than call get current time 20 times a second and do a little comparison and then go back to sleep. Okay, so right, we updated the polling. So instead of so we're added polling. Set the timekeeper. Okay, cool. And then this was all about adding the mock. Oh, that's a mistake. Let's fix that. That's another reason why I would like to review check-ins before I hit commit, because a lot of the times I'll have little mistakes that I missed. And then I'll see it here, and then I can fix it before I actually stage and commit it. Right, okay. Oh, and I was going to change that too, right? That test will also verify that we receive the quit, right? So that'll be similar to when it does log in, we see the password, right? So we'll just do this, and we'll verify a disconnected is called. So so that'll go here. So for expectations now, we expect that the logout callback is called, that login is not called because it didn't succeed, and then we will change this to be quit. And we can actually, here's a good place. We need to do this anyway to verify that this is the exact farewell message we get. And then that disconnect is called. So, oh, that should be a true, right? Actually, is that checked for when we log out? It is. Okay, good. And let me test that. Ooh, okay. That's, oh, right, because I forgot to clear, we need to clear after we tell it to after we get the login. So yeah, which means we need to do a await. So mock server await nickname, right? And then we don't really care because it's just after that we want to clear lines recede. Oh, I got that slightly wrong. Yeah, it's the colon is there. That is correct. Cool. All right. See, that's just another reason to have unit tests is they catch silly little mistakes like that too. Alrighty. So messaging. Add timeout mechanism. And add timeout mechanism. So we'll say add ability to set timekeeper. Make login attempts timeout after 5 seconds. And what else? Expect, well, have disconnect on a login timeout, right? All right. Git gut, git push. All right, so we're on to failure unexpected disconnect. This will be a little bit simpler. So we'll do the test first, like I should have done for that last one. Log into chat. So this scenario, it's this use case slightly different, right? In the normal login, we return the message of the day. But what if instead we and we don't have this callback either yet, but we tell the client the connection's been disconnected. So disconnect. We have a disconnect, but that's from the server to the from the client to the server. We need one from server to client. So return to client. How about disconnect client? Yeah, okay. Instead of return to client that message, right? And then so similarly to the last test, we'll have both of these conditions in and out, log in and log out. And that, right? And then it'll be this kind of a thing. Unexpected disconnect. Disconnect client, and then we expect something different to happen. So what we should expect, right, is we get a logged out, no login, and then should the client actually send something? No, it doesn't matter because it's been disconnected. So we'll expect, in fact, right here, we will have to clear lines received. We'll expect nothing is received by the server because the client will have been told that it's been disconnected, right? But we should expect that the client disconnects their end. So we still need to add that even though I don't need to write the code yet, I need to at least make that method. So let's put that near return to client. It needs to be similar to this though, which means we need another delegate. So it'll be disconnected delegate, which means we need to declare it. This may look like I'm programming it backwards, and I kind of am. I'm programming what type should exist, and then I make the type exist. And similarly to the method here, I'm going to want to have a set disconnected delegate. Which means I'll need that to be in the interface. Twitch connection, right? Oh, well. I'm accidentally changed the zoom factor. How much zoom factor do I really want? 160%? Hopefully that's okay. So make it pure virtual in the interface specification, and we will copy this comment. This is called to set up the callback. This is called to set up a callback to happen when, or when, to happen if, actually it will happen eventually, right? Whenever, or when. I like to think of whenever is if it's happened more than once. This should only happen once. When the Twitch server closes its end of the connection. This is the function to call, and then we'll just copy and paste that. And then we need to declare that type. And there's no message. And then we can copy and paste this comment here. And then we don't need a parameter. This is the type of function to call when the Twitch server closes. Yeah, there we go. And I think we're done there. Okay, so when... Yeah, okay, so this is good. So now the test will fail, right? Because the client's not going to actually register a delegate, and so it won't react to when we disconnect. Right? So we didn't get a logout, and it didn't disconnect. So we need to have the client actually do that. Messaging. There we go. All right. So it's probably, where was the right place to do this? When we connect, right? So when we log in, right? So we had this, excuse me, we set this message delegate. Now we'll set the disconnected delegate, and we'll make a disconnect. Okay, disconnect. We'll call it server disconnected. And there's no argument. So I'm going to put it near message received. And we'll copy from here the type. This method is called when the Twitch server closes its end of the connection. Okay, so let's make another action. And we'll call this one server disconnected. There's no message, so we just need to declare that. Okay. And we'll say handle when the server closes its end of the connection. Right. Okay. I was just going on autopilot there. In our worker where we had that big switch, we'll add the case where it belongs here. That needs a colon. Okay. Oh, it's 8 o'clock. Shoot. I need to wrap up the stream soon. We should be able to finish this in the next 5 minutes, and then I'll have to wrap up because I got an appointment, sort of. It's a raid, and it's raid night. So let me wrap this up. So what do we do when the server disconnects? We will handle it just like if there was a disconnect. Well, not exactly the same. We don't send. Actually, you know what I'll do is I'll say this if not empty. This is a message to include. If not empty, the user agent should send a quit command before disconnecting, and this is the message to include in the quit command. How about that? So then we can make it optional. We can say if not farewell empty. Right? And then, because we want to do this other stuff. Right? So what way we'll handle this is we'll just say disconnect connection. Actually, you know what? Another thing I want to do is make this a default argument to make it sure it's really optional. Now, we just say disconnect, and actually at that point we should also cancel the login timeout, login timeout, right? Maybe we'll handle that next stream. This will make our test pass, but we're missing a test for, like, we shouldn't expect a timeout and another logout callback. Yeah, see, now that fixed the test. So yeah, the next time I stream, we'll handle the flaw in the test specification where, if I collapse all these things, right now we handle the unexpected disconnect, but we don't check to make sure that the timeout doesn't trigger. So we'll have to make another test case for that. And then I'll get to receiving and sending messages, which is, you know, probably what everyone is hoping to see, but I kind of keep the best for last, I suppose. After we finish all of these tests and we've implemented the code, then I'm going to need to implement this interface connection in terms of a real network connection. And it'll actually be pretty quick because I already have a class for it in system abstractions, and it's called network connection. And its header file looks like, well, looks like this. So it's got like the raw stuff like the address and port number to connect to and delegates to call, which are pretty much just going to map one-to-one with the delegates we've been handling today, like get receiving data and then if the connection breaks. So we'll write an implementation of this class connection in terms of this implementation network connection. So it'll be a very small adapter, and then we can write a program which really does connect to Twitch. And then we'll be we'll have a bot. I'll have it say hi or something. So we're pretty close, maybe 1 or 2 streams away from doing this. And it'll get interesting, if not next stream, the stream after, where we're actually talking to Twitch. So it's just these 2 tests we need to finish, and then one or 2 other special cases where I know we have a bug where there's still a timeout pending on the connection and we have a disconnect, right? So also if you tell it to log in and then you tell it to log out before it finishes logging in, I think we'll also get a spurious log out from a timeout. So we need to fix those too, but I'll be handling that next time. So thank you, folks. We will go, let's look to see who's streaming now. We can host them. Sound good, people? So not many people streaming, but I've been watching the corner piece, and let me take a link to that. We're going to be hosting the corner piece as long as he's still streaming. Let me click on his stream to make sure he's still going. And today it looks like he's working on his game engine in C++, maybe some Python with OpenGL and Bullet. So if you haven't seen him, go say hi, and thanks for watching. See you tomorrow, hopefully.